Welcome Algebra 2. This is rational equations. The essential question is, what is an extraneous solution? Let's begin. So in rational equations, last section we did rational expressions. And the difference here when we have equations is there's going to be equal sign, or we're going to try to solve for the variable. So in this case, x over 2 plus 1/3 equals 5/6, and you do some math, and you'll get x equals 1. But how do I get this? I'm going to show you two methods of doing this today. So the first method, I want to solve this equation, is we're going to call this the equating numerators method. And what does that mean? Well, in equating numerators, we're going to make the denominators the same on both sides and then just solve for the numerators. So make the bottom same, like basically by an LCM or least common multiple, and then just solve for the tops. So let's do this. I'm going to take this equation right here. So I have x plus 3 over 2 over 12 equals 5/6. And the way to make these denominators the same, the LCM, lowest common multiple, would be 12. So I'm going to multiply the right by 2 over 2. You have to multiply the top and bottom by the same to keep it equivalent. So this is going to be 10 over 12 equals x plus 3 over 12. Since both sides are over 12, I can just ignore the over 12 part and just say x plus 3 equals 10 and solve for this. And if I do that, subtracting 3 on both sides, I get x equals 7. Now, if you want to verify that works, plug that back in. I get 7 plus 3 over 12 equals 5 over 6. 7 plus 3 is 10 over 12 equals 5 over 6. And 10 over 12 reduces to 5 over 6, so that checks out. All right, the other method is called the clearing fractions method. What that means is you're getting rid of the fraction, and then you just solve. So what you do is multiply both sides by the LCM, least common multiple. That removes the denominators, and then solve the resulting equation. So let's do that as an example. My x plus 3 over 12 equals 5 over 6. So I'm going to the LCM is 12. I'm multiplying both sides by 12, so both sides of the equation. Not 12 over 12, just 12. As long as you do it on both sides of the equation, you can do it. It's legal. So what's going to happen is these 12s are going to cancel right here, because that's like 12 over 1, 12 over 1. And on the right-hand side, this 12 and 6 are going to reduce. That goes to 1. This goes to 2. So what I'm left with is x plus 3 equals 5 times 2, 10. And that looks familiar like last time, so x equals 7. And that's the same answer we got last time. So both methods work whatever way you want. Or if you have another method, that works too. I don't care. Let's try something else. I want to solve this equation. Now, we have variables in the bottom still, but we can do that. That's perfectly fine. So what I'm going to do is I'm going to solve using that first method. I want to make the denominators the same. So 3 over x equals 8 over x minus 2. And I want to make the denominators the same. So I multiply by basically the left side, just x and x minus 2. The LCM, the lowest common multiple, will be x times x minus 2. So I'm going to multiply the right side by x over x, and the left side by x minus 2 over x minus 2. When you get here, you'll get 3 times x minus 2 over x times x minus 2 equals 8x over x times x minus 2. Since the denominators are the same, that's okay if they're variables. We just solve for the tops. So 3 times x minus 2 equals 8x. I'm going to distribute that 3, so I get 3x minus 6 equals 8x. And I'm going to subtract 3x from both sides. So what you're going to get when you do that is I get negative 6 equals 5x. Divide by 5. Cancel out those, so I get x equals negative 6/5. All right. Now let's verify using the other method. So this is the method clearing fractions method. So rewriting that equation, 3 over x equals 8 over x minus 2. I want to multiply both sides by the LCM, which will again be x times x minus 2. If you don't know, just both sides, everything multiplied together will always be a common multiple at least. So I'm going to multiply by x times x minus 2, and x times x minus 2. So what's going to happen on the left, the x's here will cancel, and the x minus 2's will cancel. So I'm left with 3 times x minus 2 equals 8 times x. That's similar like last time, so we get 3x minus 6 equals 8x. Subtract 3x on both sides, I get 5x equals negative 6. And divide by 5, and you get x equals negative 6/5. So there's your answer. Don't leave it as a mixed number. Leave it as improper fraction. All right, let's try something else. So this is kind of weird here. I want to solve this one. I have 3 things going on. So how do I want to do this one? I'm just going to move it over here so I can see it a little better. So the first thing you might want to do is you might want to, I don't want to do that. I'm going to solve by that method of making all the denominators the same. And one thing to help you out here is, a squared minus 4, I can rewrite this equation. I'm going to actually rewrite this fraction. As on the right-hand side, it's going to be 4, that factors to difference of squares, a minus 2 times a plus 2. And on the left side, it's 1 over a plus 2 plus 1 over a minus 2. So each fraction I want to have the same denominators here. So it's going to be a minus 2 times a plus 2. On the first one, I'm going to have to multiply by an a minus 2 on the top and bottom. And on the second one, I'm going to have to multiply by an a plus 2 on the top and bottom. So when you do this, I'm going to have on the left side 1 times a minus 2, or just a minus 2, and over a minus 2, a plus 2, plus 1 times a minus 2, so just a plus 2, a plus 2 over a plus 2 times a minus 2 equals 4 over a minus 2 times a plus 2. Since all the denominators are the same, I can ignore them and just use the numerator. So I get a minus 2 plus a plus 2 equals 4. Combining like terms on the left, the a's combine to 2a, and negative 2 and positive 2 just go to 0. So I get 2a equals 4. And divide by 2 on both sides, and get my a equals 2. And if you want to check, you can always plug this in. So if I plugged in a equals 2, I get 1 over 2 plus 2 plus 1 over 2 minus 2 equals 4 over 2 squared minus 4. So what's going to happen? You get 1/4 plus 1 over 0 equals 4 over 0. Why would I give? And so that's kind of weird, right? So we had our solution of a equals 2, but when you actually plug this in, it doesn't work out. And the reason it doesn't is that we have an extraneous solution here. So sometimes you solved something and you get a solution, but they're not valid if you insert them into the original equation. So this is why you always have to check. In that last case, when you plugged in that 2, it didn't work out because you're dividing by 0 and you're not allowed to do this. So even though 2 looked like a solution, it's actually not a solution. We don't have any solutions in this case. So you always have to check. That's what I mean by extraneous solutions. Solutions that are not valid if you insert them into the original equation. Solutions that don't work. So I'm going to take this next example right here. We'll do another one. And I'm going to do this by the second method, the multiplying by the lowest common multiple, getting rid of fractions. So in this case, I'm actually going to factor out. I'm going to move this over. I want to start on the left side. So I'm going to factor out on the left. So I get 4 over, and if you're factoring that, it's going to be 12 and negative 8. So your two numbers are going to be negative 6 and negative 2. So it's 4 over x minus 6 times x minus 2 equals 1 over x minus 6 plus x over x minus 2. All right, I want to multiply both sides by the LCM. So it's going to be x minus 6 minus 2 times x minus 6. And I'm also multiplying this one, x minus 2 times x minus 6. And this one, x minus 2 times x minus 6. Okay, you multiply all of those. I'm going to cancel the x minus 6's. Let's do that a different color. X cancel these x minus 2's. And nothing cancels, and then these both cancel on this side. So what I'm left with is 1 times x minus 2, so x minus 2, plus x times x minus 6 equals 4. And I'm going to solve. So distributing this x, I'm going to get, it's going to be x minus 2 plus x squared when you distribute, minus 6x equals 4. And combine like terms, I'll get x squared. 1x minus 6 is minus 5x minus 2 equals 4. And when you see a quadratic, I want to think quadratic equation factoring, so I'm going to actually subtract 4 on both sides. So what you're going to get is x squared minus 5x minus 6 equals 0. Now this goes back to factoring. I want to solve my solutions for x. So if you factor this right here, I don't care if you do the x or whatever, however you do this, I want to show you this, and you're going to get negative 6 and positive 1. So it'll be x minus 6 times x plus 1 is going to equal 0. So your two solutions you say are x equals 6 from the left side and negative 1 from the right. However, we have to check and see if you plug those in. So I'm going to go back to my original equation. I'm going to just drag it down here. I'll drag it down here just so we can look. That'll make it easier. So my problem is if I plug in x equals 6, if you plug that in right here, you get 1 over 6 minus 6, which is 1 over 0. So it does not work. X equals 6 does not work. If you plug in negative 1, it will work because you'll get, so if you plug in x equals negative 1, you get 1 over negative 1 minus 6 plus negative 1 over negative 1 minus 2 equals 4 over whatever this is, negative 1 squared minus 8 times negative 1 plus 12. This will come out to some numbers, and this is okay. But this one you're dividing by 0. So your only solution is actually x equals negative 1. That's it.